Good morning, guys, or afternoon, whenever you are viewing this. I'm going to do some of the review with you. The other answers will be sent out through my 101. So I'm going to do about 3 in the first section. So we have simplifying radicals. So what we're going to do is break down the numbers. And the way that I taught you is that couples go out, and that numbers that don't have something to go with it stays in. So if we look at, say, uh, 384, I broke it down to 16 and 24, but it doesn't matter what you break it down to. But see, I have my couple here. Okay, so then I have two couples. So I have 4 times 2, which is 8, and then square root of 6 stays inside because that's the one that's left inside. Okay, so all the rest are worked the same way. So you just have to, it doesn't matter how you break them down, as long as couples go out and singles stay in. So if we look at number 7, we're solving by graphing. So we want to graph this in vertex form. Well, it is in vertex form. Its vertex is 0, 0, 0, 6, sorry. And in case you don't know, it's also the formula negative b over 2a. But in this case, there is no parentheses, so we know that's going to be our y-intercept. The c is our y-intercept. So then it's a negative x squared. So that means that I'm going down. And then what I'm going to do is graph a line across at 2. And where those two lines meet up is the solution. So it's where x equals 2 and x equals negative 2. So number 8's work the same way, so I'll let you try that one on your own. So let's move down to solving by square root, which is why we work the top couple together, because in solving by square root, you need to know how to simplify the radical. So let's do 10 and 12. Yeah. So number 10, I'm going to get x squared by itself. And if you notice, when I start solving, I have x squared equals negative 6. So when I square root this, I know my answer is going to be imaginary because of the negative underneath. So I need an I. 6 cannot be broken down, so 6 stays underneath. And then they always have plus or minus on the square root. Solving by square roots always have plus or minus. Alright, so let's do number 12. So I'm going to subtract 3. Divide by 9. And I don't think that simplifies very nicely. So I leave it a fraction. I don't think it does. Let me grab a calculator. It does not. So what we would want to do if it doesn't simplify, just leave it like this. Because when we square root this, the I will come out because of the negative. It's plus or minus always. Square root of 133 cannot be broken down. And then the square root of 9 is 3. Alright, so let's move on to the next page, which is solving by factoring, the next way to solve quadratics. I'm going to do number 16. That's probably the one that we would have most trouble with. 2n squared plus 13n plus 15. So in order to solve by factoring, you have to get it equal to 0. Okay, and so then I'm going to do the slide and divide because the 2 in front. So I slide it back. factor this. But the thing is, we generally forget on the slide, we forget the divide. And we divide by that number that that got slid back. So this can't be simplified, so it's 2n plus 3. This can, so it's n plus 5, and then I solve each parentheses. So to solve each parentheses, this one, n plus 5 equals 0, so n equals negative 5 when you subtract 5, and 2n plus 3 equals 0. And if you need to, you can work this out, but you don't have to because n equals negative 3 over 2. So how about number 15? So I'm going to get it equal to 0 and put it in standard form. So notice that this needs to go between those two in order to factor. So again, it's a slide and divide. X squared plus x minus 2. Positive 2 and a negative 1. Multiply to this and add to that. Divide by 2, I think. Yeah. So this turns into x plus 1. This one has to slide up, so 2x minus 1. So x equals negative 1, and x equals 1/2. Alright, so let's look at number 17 and 20. So 17, I'm going to solve by completing the square. So I have to move the constant first. Then I have to divide by the 2 that's leading off, because whenever you solve by completing the square, you can't have a number in front. Oh gosh, sorry. So then to complete this, it's negative 10 divided by 2, which is 5, and 5 squared is 25. N minus 5 squared is how that would be factored. And then this is 4. So then I square root both sides. N minus 5 equals 2. N minus 5 equals a negative 2, the square root of 4. And so then n would be 7 and 3. Alright, so let's jump to number 10. So number 10, notice that the constant still needs to be moved. So 10b squared minus 20b minus 26. Just checking my math here. So then I divide everything by 10. Well, that doesn't work out very nice for this side. So what I'll do, I'm going to leave it like that. Okay, so now I'll complete it. So it's negative 2 divided by 2 squared is 1. That's 1. B minus 1 squared. That's factoring this. And then negative 17 over 10 plus 1 will be the same as saying negative 17 over 10 plus 10 over 10. That's essentially saying the same thing. So if I want to combine these two, it would be negative 7 over 10. I would square root this. b minus 1 equals I square root of 7 over 10. Now you can't leave a radical in the denominator, so I would multiply by square root of 10. So b minus 1 equals square root of 70 over 10. And then I add 1. And that one became a lot longer because I needed to rationalize the denominator. And that's why it took a little longer to solve that one. All right, so let's move on to these patterns of, the i's. So to go back over, I is I to the first, I to the second is negative 1, I to the third is putting these two together, negative 1i to the fourth is 1. That's negative 1 times negative 1. So I would write these first on your test for Thursday. So I to the 55th. So it repeats every 4 times. So if I divide that by long division, my remainder is 3. So what that means is I'm on I to the third, which is negative 1i, or just negative I. Alright, so a quadratic formula, you want to get it equal to 0, or put it in standard form is another way to say that. Here's a, b, and c. So x equals negative b, which it's going to turn that positive, plus or minus the square root of b squared minus 4ac all over 2a. So, once I do that, I want to simplify everything underneath. So that's 4 plus 84, whenever you multiply these 3, over 14. 2 plus or minus 88 over 14. Notice I'm working on this square root the whole time. Okay, and that's, what would that be? 4 and 22. So 2 plus or minus 2 square root of 22 over 14. And then now I can simplify these 3. Never go into there. Never simplify into there. But I can do these 3. And they're all 3 divisible by 2. So if I take a 2 out, I'm still left with the 1. I don't have to put the second one right here. And then that's 7. Alright, so let's jump to number 28 and 30. So 28 and 30 have our imaginary section, our complex numbers, which came from 4.2. So what this is meaning is 4 plus 6i is really 4. This is our real, and then this is our imaginary. So 4 plus 6i is here. So we want to know the distance. So what we do is we make a little triangle here. So this is 4, this is 6, and we need to know this. So 4 squared plus 6 squared equals c squared. 16 plus 36 equals c squared. 52 equals c squared. And that's 4 and 13. 2 squared of 13. Okay, and we don't put plus or minus because we're talking about a distance here, so it can't be negative. Alright, so let's do some rationalizing this. That may be where you have trouble with. so we're going to rationalize on number 32. So in order to rationalize, we want to do the partner that goes with it. So notice the only thing that changes is the imaginary part. So I multiply by what's called the conjugate pair. So there's a lot of distributing. So that's 15 plus 30i minus 9i plus 18i squared. So that's distributing everything on top over 9 plus 18i minus 18i minus 36i squared. Okay, and then now I'll do some simplifying. So these are going to cancel. This I squared will make this negative 36 positive 36. This negative I squared will make this negative 18. So now I can put together this and this, which is negative 3. I can also put together these two, which is positive 21i. And then 36 and 9. Now you can go a step further by simplifying by 3. So negative 1 plus 7i over 15. Okay, so the discriminant tells us really how many solutions we would have and what type they are. And so the discriminant is what's underneath the square root on the quadratic formula. So what I'm doing is, in order to actually tell what the discriminant is, it has to be in standard form. So I don't know if you notice, almost every time we're solving quadratics, it has to be in standard form, except for solving by square root. It does not have to be. So here's our a, b, and c. So it's 5 squared minus 4 times negative 2, which is a, negative 4, which is c, 25 minus 8 times 4 is 32. So that gives us a negative 7. Okay, so what that would mean is there's a negative 7 underneath the square root in the quadratic formula. Sorry. So the negative 7 tells me that it would be imaginary. And with imaginaries, there's always 2. They travel in partners. And so that's why there's always 2. That's the plus or minus to every problem. Okay, so on the back, we'll do some inequalities. And I'll help set you up on one of the word problems. So let's do 36. So 36, to find the vertex, x equals negative b over 2a. So that's negative 12 over 4, which is negative 3. Wow, sorry. And then to find the y of the vertex, you plug in negative 3 for x. And so then you get positive 3. So negative 3, positive 3 is the vertex. My a is 2, so it goes up 2 over 1 and then up 6. 1 over too far. And this is going to be a dashed line because it's not equal to. Now, if you don't know which side to shade, that's a terrible line, sorry. You can pick 0, 0, okay? So if I pick 0, 0, I plug in 0 for y, 0 for all the x's. 0 is less than that 0, 21. So the question is 0 less than 21? Again, I plugged 0, 0 in for x and y in the original equation. So yes, 0 is less than 21. So I shade where on the side of the line that 0, 0 is on. 0, 0 is not in here, so that's why I shade out here. Alright, so 2 more. We're going to do 37. So 37, I'm going to add 4. Why am I adding 4? I'm not going to add 4. I need to solve this, and I'm going to try by factoring. So let's see if this can be factorable. So x squared plus x minus 20. Notice that in factoring, it's got to be in standard form. So x plus 5, x minus 4. So yeah, it solves. X equals negative 5. X equals 4. Now, what I want to do is I'm going to go ahead and plot negative 5 and 4. They're going to be open because of the inequality tells us it's not equal to. I'm going to plug in 0. So 0 squared plus 0 minus 4 is greater than 16. So is negative 4 greater than 16? False. False. So when it's false, you don't shade where 0 is. And now I can write my answer. X is less than negative 5 or x is greater than 4. Alright, and last one, we'll do one of the word problems together. Let's do 40. So 40, it says the original dimensions of a rectangle are 20 by 23. When both dimensions were decreased by the same amount, meaning you have a rectangle that's inside, and these lengths are going to be the same, so that's going to be our x. By the same amount, the area of the rectangle decreased by 120 centimeters squared. So if I find out the original, 23 times 20 is our original. Which is 460. Okay, I'm going to set up an equation. 23 minus 2x, 20 minus 2x needs to be equal to the new area. Have we figured out the new area? The new area will be taking the original and decreasing it by 120. So what I'll do is once I find that number, 340, that is what I plug in here. And we're going to just solve this by calculator. So you don't have to solve it by any other method, but you can. And on my review, I actually solve it by hand, but you don't have to. So what happens is you end up with two solutions. So this would go in y equals, and you would find the zeros. Okay, and when you do, you would find the zeros would be x equals 40, not 40, excuse me, 20. I'll try to type that in real quick. I'm typing it in right now. Hopefully you're trying it on your own too. Okay, so once I type it in, you can see my equation. I can type it exactly how I wrote it. Okay, obviously I can't see it all, so what I want to do is go to Window, and I want to zoom out. I want to zoom out over here somewhere. So there they are. So I'm going to escape to get out of that. Analyze 0. So you would shade over. It's 20. Escape out of that. Do it again. I'm going to do to this one. 1.5. Escape. So 20 and x equals 1.5, but only one of those could be my solution. Well, if you were to take 20 and plug it in for x here and here, you would not get 340. You would end up with a negative number. So 20 is too big. So let's actually see what the question says. Find the dimensions of the new triangle. So if x is 1.5, it'd be 23 minus 2 times 1.5. Sorry, give me a second. So 23. So I plugged it in for the one of the sides that we showed by the equation, 23 minus 2x. So 23 minus 2 times 1.5. My calculator's not working. 20. Can't see my work. So that's one of the sides. That's in centimeters. And then the other one would be 20 minus 2 times 1.5, which that's 3. So then 20 minus 3, 17. And so the dimensions are 17 centimeters by 20 centimeters. So the application isn't on the first part of the test. The application's on the second part of the test. So you would make sure that you study all the first part. Before I got to the last one, everything on before that very last problem, number 40, is on the first part, which is non-calculator. So I will send out some more videos tomorrow night with how to do the other ones, the other practice that I gave you on the first test day.